Welcome to training on System Builder for the Dell EMC HPC System for Research. My name is Neil Klosterman and I'm the HPC Product Manager. In this training I will provide an overview of the System Builder showing how a HPC system can be designed and entered into sales tools for quoting. Links to HPC System Builder can be found on Sales Edge by searching HPC System Builder or on the system dashboard pages. Link is shown here for the HPC System for Research. For System Builder, in Step 1, you are provided the options for the type of cluster that is being designed. There are options for traditional x86 CPUs, many-core options for Xeon Phi or NVIDIA accelerators, or some hybrid between the two. I will choose the hybrid option. There's also the option of clicking on the More button in order to get additional information around the selections that are being made. You can also select if you wish to include large memory nodes as part of the cluster if the customer has those requirements for their workload. And finally, the cluster management tool is chosen between Bright Cluster Manager or Intel HPC Orchestrator, both of which are available for sale today from Dell EMC. At the very bottom, you'll see assumptions that are being made into the logic for System Builder and how the decisions are being made in the end. And click Next. Step 2, you can choose the many-core, compute, or accelerator options. Because the PowerEdge C6320P server is the newest additional in this release, I will select the Intel Xeon Phi socket-based processor. Please reference the HPC System for Research technical training for more information on the PowerEdge C6320P and Xeon Phi. In Step 3, you would choose the processor types for the different compute nodes in the cluster. For the traditional compute nodes, most all of the Intel Xeon V4 processors are available. I will select the E5-2690 for this example. Next, you will choose the Xeon Phi processor options. More information around the processor details can be found by clicking Why do we ask this question? For this example, I would choose the Xeon Phi processor 7250. Wrapping up this step, choose a processor type for the large memory nodes. These are the processor options available on the PowerEdge R930. Next, for Step 4, choose the memory configurations for the different compute nodes in the cluster. There are predefined memory recommendations for each server type based on the filling of all the DIMM slots in the server with the different memory sizes in order to get the best memory performance. This can always be changed once the solution ID is entered into the sales tool. At the bottom of the page, there are questions specific to the network fabric. You can choose between 10 gigabit Ethernet, FDR or EDR InfiniBand, or Intel OmniPath. The option is available then for a non-blocking or 2-to-1 blocking fabric, and there is information on the More link around those options. Step 5, you will choose your server form factors for the different compute node types. For the traditional compute nodes, I will choose the Shared Infrastructure 2U High Density option, which is our PowerEdge C6320 server. For the Xeon Phi selection, there is only one form factor supported with the PowerEdge C6320P, and the same applies for the large memory nodes, which is the PowerEdge R930. Click Next. Because there is no PowerEdge C4130 included in this configuration, Step 6 is skipped, where you would choose the config type. In Step 7, you will choose how to size the overall configuration. The options are available to size the HPC system based on the number of compute nodes, the expected theoretical performance for the HPC system, or sustained performance for the HPC system. Sustained performance is based on the expected efficiency for the network fabric in the HPC system. For this example, I will size the opportunity based on the number of compute nodes. In Step 8, you can enter in the number of compute nodes needed for the different compute node types. Traditional compute nodes, I will say 128. with 16 Xeon Phi PowerEdge C6320P servers, and I'll keep the count at 2 for the large memory nodes. The final questions will primarily focus around the storage subsystem for the overall HPC system. For this example, and to show all options, I will select home and scratch directories are required, but it's entirely possible a customer may only need one or neither option if they have existing storage. Step 10 will allow you to size the storage subsystem based on different requirements. If the customer has a capacity or performance requirement, the storage can be sized based on that, or based on best practices developed by our HPC Innovation Lab, a recommended storage configuration will be included. For this example, I would choose capacity for sizing. Step 11, you will want to enter in the amount of capacity for the two storage types. If throughput was chosen, you would enter in the storage bandwidth requirements from the customer. For this example, I will keep the default options, which is the base minimum for HPC storage subsystems. Next, we will jump to step 13, where we can account for any additional fabric ports that are needed as part of the cluster. If the customer had existing HPC storage or some other components that is going to connect to the larger HPC system, those network ports can be allocated here to ensure everything can be connected under the same network fabric. For this example, I will say we require an additional 4 network ports. Finally, System Builder will output responses to all the questions answered. This opportunity can be taken to review the answers and make any necessary edits if something was entered incorrectly. Once all responses have been validated, you can click on Get Recommendation, and System Builder will implement the logic design from our HPC Innovation Lab to build a BOM for the HPC system. There will be some delay while that logic is implemented and the BOM is built. Be patient, and the solution ID will be made available. In the final screen, there are 2 important pieces to showcase here. First is the solution ID created for the HPC system designed throughout the list of questions. Second is a PDF which can be downloaded and provide the HPC system details with the configuration BOM. After System Builder produces a solution ID, you can take that number and enter it into a Dell sales tool in order to produce quotes. The sales tool will look up the solution ID and import the BOM into the sales tool. From here, additional changes can be made, corrections to any errors, and next steps to have quotes created. This concludes the System Builder training for the Dell EMC HPC system for research. Thank you.